Hello all, welcome to another one session of ChemFlix, and today we're going to discuss about the basics of organic chemistry, that is exactly the fourth chapter of class 10, that is about carbon and its compounds. So once again, welcome all to my channel ChemFlix. Okay, so let's see with an activity. It is 4.1 of your chapter, that is about making a list of 10 things or some things you have used or consumed since the morning, and compile this list with the list made by your classmates and sort the items into the following table. And if there are items which are made up of more than one material, put them into both of the relevant columns. As you know, it is now we are all stuck in our home due to this COVID pandemic, and now all the things that we are doing now in our home is these taken the we are taking the laptops and coming in behind coming in. So I just prepared you some of these list of things that we used in our home from the morning. They are mainly, okay, this is just a little bit of examples like water, wash basin, toilet paper, toothpaste, toothbrush, soap, towel. You have seen a lot of things that we used in our since morning, and I've just classified it into 3 groups. You can see here things made up of metals like steel, glass, spoons, plates while you are having food, and things made up of glass and clay like cup, plate, toilet pot, mirror, like there are some more things like clay you have to find out, and the others I'm just including some of the examples like book, pen, laptop, mobile, TV. Okay, during this lockdown condition, okay, during this pandemic condition, you are always using your laptop, mobiles and TVs. Okay, so these are the things. So the explanation, what is the common thing that you can find out why you are considering this water, wash basin, toilet for toothpaste, toothbrush, soap, towel, steel, glass, spoon, plates, mirror, mobile, laptop, pen, book, etc. are we are using a variety of materials in our daily life. As you can see here in this tabular column, this just gives us a brief idea of what we are using or what we are consuming from the day. A significant number of objects consist of organic compounds. Okay, a significant number of objects consist of organic compound, and for example, all plant products like fruits, seeds, paper, all soil products like clay, pot, all polythene products like plastic, rubber, etc. are all examples of organic compounds, and this vast presence of organic compound significates its importance in our life. So what do you mean by this organic compound? So in this organic compounds are mainly made up of this carbon. So we have to study about carbon in detail. So that is all about this chapter, that is carbon and its compounds. And of course it's me, I'm Ravina. And food, clothes, medicines, books, or many of the things that you listed all are based on this versatile element of carbon. And in addition, all living structures are carbon based. So all living structures are carbon based, including us. Compounds of carbon are widely distributed in nature, and the number of carbon compounds is larger than that all other elements put together. Do you know how many elements are now in the periodic table? Of course, it's 118 elements are there in our periodic table. I will show you the periodic table in our coming slide. And the earth crust, one more thing I just want to tell you, that is in the earth crust, it is only 0.02% of carbon in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum. And in the atmosphere, you can see about 0.03% of carbon dioxide. Okay, this 0.03% of carbon, it is in the form of carbon dioxide. Okay, and this comes your periodic table, and here you can see the exact position of carbon, and this is the right side of the periodic table, and the right side of the periodic table you can see here it is a p block element, and it is, of course, it is non-metals. Okay, you already studied about the periodic table, where the non-metals and where the metals placed in the periodic table. So here in the right side of the periodic table you can see this carbon, and of course this periodic table contains 18 groups, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You know, this vertical columns can be called as groups. So here 18 groups and 1, 2, 3, 4, 5, 6, 7. 7 periods. So in the periodic table there is 7 periods and 18 groups, and here this carbon, it is in the 14th group. Okay, carbon, it is in the 14th group. Since this group starts with carbon, this group is named as carbon family. So this carbon family, that is in the 14th group element, or you can see the carbon here, the atomic number of carbon is 6. Now we're going to see the carbon in details. So here is carbon. So carbon, the atomic number of carbon is 6, so that the electronic configuration can be written as 2, 4. And of course the valency is 4. That means the combining capacity, that is how many electrons it needs or how many electrons it loses to attain the nearest noble gas configuration. For example, in the case of carbon, the nearest noble gas configuration is neon. You know, neon is atomic number 10. So how many electrons it needs? For example, here carbon is the atomic number 6 and the valency is 4. So how many electrons it needs? 4 more electrons it needs to attain the nearest noble gas configuration. And of course the valence electron, that means the electron which is present in the outermost shell. The valence electrons, number of valence electrons is 4. So this is a typical representation of carbon atom. There you can see 6 neutrons in the nucleus and 6 protons in the nucleus. Okay, of course protons and neutrons together can be called as nucleons, and there is 6 protons and 6 neutrons in the nucleus, and 6 electrons that are revolving around the nucleus. And you can see there are 6 electrons and 6 protons, which means carbon maintains their electrical neutrality. You know, 6 protons, that is 6 positive charge, 6 electron, that means 6 negative charge. So the carbon possesses, or carbon maintains, an electrical neutrality in its atom. So this is a carbon 14, this is the carbon family. You can see here it's starting from carbon. There is silicon, there is germanium, there is tin, lead and flerovium. And of course the valency of all these elements are 4, and the valence electrons of all these elements are 4. Okay, so that is all about this carbon family and the position of carbon in periodic table. And here comes the why so many carbon compounds in nature. That is a question. Why here you can see that we already listed so many things in the tabular column, and there we concluded that the versatile property of the carbon, there you can see so many properties, so many compounds which are made up of carbon, and there is exactly one branch of chemistry called organic chemistry is there. Why so many carbon compounds in nature? Think about it. Why so many carbon compounds in nature? It is because carbon is chemically unique. One of the main property is that carbon is chemically unique. And why carbon is chemically unique? Only carbon atoms have the ability to combine with themselves to form long chains. You can see here these are long chains which are made up of carbon, and only carbon atoms have the ability to combine with themselves to form long chains. Okay, and this particular property can be called as catenation, that we are going to discuss in our coming slides. Okay, so this is the reason because you can see so many carbon compounds in nature, or the carbon compounds, carbon atoms have the ability to combine with themselves to form long chains. Clear? And occurrence of carbon. Carbon is found in the atmosphere, inside the Earth's crust, and in all living organisms. That we already see that in the atmosphere about 0.03% of carbon is obtained as carbon dioxide, and inside the Earth's crust about 0.02% as hydrogen carbonates, etc. And in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas, etc. And carbon is found in free state as diamond. You know, carbon. Diamond is one of the allotrope of carbon. Graphite is another one allotrope of carbon, and fullerene another one allotrope of carbon. So what do you mean by these allotropes? So allotropes are nothing but, or allotropism is the property of some chemical elements Now we are dealing with carbon. So property of carbon to exist in two or more different forms in the same physical state. They are in the same physical state but different forms. Exist in two or more different forms in the same physical state. So here allotropes a different structural modification of an element. The atoms of the element are bonded together in a different manner. So here in the graphite you can see carbon atoms are arranged in this particular shape, and in carbon nanotube you can see carbon atoms are arranged in this particular state, and fullerenes, diamonds, etc. So what do you mean by this allotropes? Allotropism is the property of some chemical elements to exist in two or more different forms in the same physical state. Okay. Then comes our bonding in carbon. Okay, how this bonding, how this carbon attaches with another, or how this carbon comes in contact with another atoms. Okay, that is called this bonding, and exactly the bonding in carbon atoms are covalent bond. Okay, why it is covalent bond? Or what do you mean by covalent bond? In this slide we're going to discuss about that. You know the atomic number of carbon is 6, and of course you know that the electronic configuration is 2, 4, and it has 4 valence electrons. Okay, and it can attain stability by gaining 4 electron or losing 4 electron or sharing 4 electron with other atoms. Which means for attaining the stability, that means octet configuration in its outermost shell, it needs to gain 4 electron, or it needs to lose 4 electron, or it needs to share 4 electrons. You know the outermost shell of the carbon contains 4 valence electron, and in order to attain the stability, carbon needs these things. And it does not gain 4 electron because it is difficult for the 6 protons to hold 10 electrons. So while this carbon gaining 4 electrons, what happens? Only 6 protons are there in the nucleus, and it is difficult for the 6 protons to hold 10 electrons. And it does not lose 4 electrons because it needs a large amount of energy to lose 4 electrons. For losing 4 electrons, it needs much more energy. So it's also not possible. So losing of electron and gaining of electron, these two things, it's not possible. And the only possible way is to share 4 electrons with other atoms to attain the stability, resulting in the formation of covalent bond. So what do you mean by this covalent bond? Covalent bond is a type of molecular bond where the sharing of electron pairs between the atoms. What happens there? That involves the sharing of electron pairs between the atoms. So that you mean by a covalent bond. That is actually covalent bond. So covalent bonds are formed by the sharing of electron pairs between the atoms. You can see here sharing of electron pairs between the atoms. Since carbon atoms needs 4 electrons to attain stability, its valency is 4 and it is tetravalent. So what do you mean by this tetravalency? That means there is only 4 electrons in its outermost shell, and it needs 4 more electrons to attain the stability, and therefore you can call it as tetravalent. Carbon atom is tetravalent. And of course here covalent bond, definition of covalent bond. Covalent bond is also called a molecular bond. It's a chemical bond that involves the sharing of electron pairs between the atoms. And here you can see the exact difference between covalent bond and ionic bond. You already studied about ionic bond in your previous chapter and also in previous class. So here in sodium atom, it gives 1 electron, transfer of one electron, complete transfer of 1 electron to the chlorine atom for attaining the stability. You know the electronic configuration of sodium is 11 and chlorine is 17. That means the outermost shell containing 1 electron in sodium and 7 electron in the chlorine, and in order to attain the nearest noble gas configuration or the octet configuration, sodium donates its 1 electron to the chlorine atom. Thereby sodium forms a negative charge, sodium forms a positive charge and chlorine forms a negative charge, and there you can see an ionic bond. That means the electrostatic force of attraction between these both opposite charges. Okay, that is how ionic bond is formed. But in the case of covalent bond, you can see here the exact sharing of atoms, sharing of electrons between these two atoms. Okay, sharing of electrons between these two atoms. So that is exactly what you mean by this covalent bond and what's the difference between ionic bond. Okay, so hope you all like this video, what we studied or what we discussed today. So thank you all. And if you're new to this channel, please make sure you click the subscribe button, and also if you like this video, click on the like button please. And of course, thank you all. Thank you.